Hello, my name is Anthony Villalba, and I'll be going over the questions I got wrong over the exam and explaining which answers are correct and why. Okay, for the first question, it's going to be question number 3, which goes over which one of the following exhibits dipole-dipole attraction between molecules, and the answer is B, AS hydrogen 3. Now, something that helped me learn or see differentiate between these different answers is that dipole-dipole, as we know it, has the molecule has one side of the molecule has greater electron negativity than the other side, so one tends to pull more electrons towards its side. One side is gonna have more electrons than the other. What helped me the most to decide to see why this one was our answer, why this molecule was dipole-dipole or exhibit dipole-dipole attraction, was drawing the Lewis structure and just thinking of it as a fidget spinner. We know that fidget spinners, when you spin them, they spin equally and they just spin. But if we think of it, if we look at like the Lewis structure of the element or the compound, whatever you want to call it, and let's say that this is our center point, and we just try to like spin it around like a fidget spinner, immediately we're just gonna think that it's unbalanced, that it's gonna be all wobbly and everything. It's not gonna be balanced. Think of it also as like a wheel. We try turning it, spinning it, it's gonna be more wobbly, shaking and everything, right? So that gives us the idea and the reason that it's dipole-dipole. Now, if we look at our options for the other answers, such as XeF4, when we draw the Lewis structure and we see and we point, we say that Xe is our center point and we try to spin it, it balances perfectly out, and that just tells us that it's a London dispersion force. And so goes for CO2, boron tetrachloride, or no, trichloride, boron trichloride, whatever you want to call it, and chlorine dichloride, I believe. All of these ones are going to be London dispersion forces, since if you think about it, just like I said earlier for XeF4, we say that, let's just say that the C is the center point and we try to spin it, it's going to spin equally, just the same as this one. Our center point is right here, we spin it just like a fidget spinner, it's going to spin equally, there's isn't going to be no imbalance. As for our boron chloride, it may look like it's unbalanced, but if we just shift or angle the chloride that looks like almost like a Y, like almost something like that, and we spin it, it's just gonna balance out perfectly. There isn't gonna be one side isn't gonna be more heavier than the other, and that's what pretty much a dipole-dipole is. Alright, next moving on to the next question. Question number 5, which of the following have the lowest boiling point? Right. For boiling point, we know that the stronger, there's a correlation between bonds and boiling point. The stronger the bond, the higher the boiling point. Think of it as trying to break a toothpick. The weaker the bond, the easier you're gonna break that toothpick, right? Now, the stronger the bond, the harder it's gonna break. Let's say a steel beam or something metal. If you try to break that bond, or you're gonna need more energy to break that bond. So that's how boiling point and bonds are connected. Now, looking towards our answers, we need to see and understand which type of bonds our answers have. For this question, our answer is going to be SiH4. Since our question is asking us for our lowest point, lowest boiling point, it means we're gonna choose the one that has the lowest bond type, and that is London dispersed force, which requires less energy to break that bond and to boil it. How do we know that this is a London dispersed force? Well, just like the previous question, we use that fidget toy analogy where this is our center, we spin it around. If it spins equally, then it's a London dispersed force. If it did have one side like heavier than the other, then we can say that it's a dipole. Now, we know right off the bat we see hydrogen, and many people will say that this would be a hydrogen bond. But the thing is, a hydrogen bond cannot happen unless there is nitrogen, oxygen, or fluorine. So this compound, this molecule, or whatever the proper term is called, can only be a London dispersed force. Now, why is this the correct answer? Well, if we look into our other options, such as the pH3, when we draw the Lewis structure and do the fidget spinner analogy where we spin it and everything, we notice that this side tends to pull more, or it's uneven. So this just tells us that this is a dipole. Same goes as the H2S, where this is our center, we spin it around, it's gonna be uneven, wobbly, you get the idea. Same goes for the H chlorine, where this is gonna be our center, we spin it, one side is gonna be heavier than the other. So these three are gonna be our dipole. They're not the weakest, but they are strong. This type of bond is stronger than London dispersion. Now, lastly, our H2O. This one's a hydrogen bond. There being hydrogen and oxygen is what makes it a hydrogen bond, making this one our strongest bond, intermolecular force, making this one our highest boiling point. But that's not what the question was asking. The question was asking which of the following should have the lowest boiling point, which was SiH4. Now, going to the next question. Of the following substance has the highest boiling point? Just like the previous question. Now that we know that the weaker the bond, or the weaker intermolecular force is, the lower the boiling point. Vice versa, the stronger the intermolecular forces, the higher the boiling point. Right then, so our answer is going to be E, HOCH2OH. Right. But why is that? Well, there's a big reason. Majority being that it's a hydrogen bond. It's not the strongest, but it is one of the strongest bonds that there is. And as you might have already noticed, our first answer A, is also a hydrogen. So why is this one our strongest intermolecular force, or being our? Why would this one be? Why would this one have the highest boiling point? Well, compared to when we take a closer look, this molecule has two hydrogen bonds, which is most likely to be more stronger. It will take will require more energy, and compared to our first option, our first answer, it's a hydrogen bond, but it only has one hydrogen bond. But not only that, the molecular weight compared to our answer is greatly a lot, meaning that this would just require our answer, which is 62 grams per mole, requires more energy to boil rather than our first answer, the answer A, this one, which is just 46 grams per mole, requires less energy than our answer.